Hello, students. Today we are doing the lesson 8.2.2 together. Before we do the lesson 8.2.2 together, please have your homework out. Check the answer key. If you have any question, email me. I will help you. And here we go. Problem 835. Okay, 836. 37, 38, 38, 8, 39. This should be 839. 40. Okay. All right. So the lesson today, how close is my sample? Inference from random samples. In the previous lesson, you studied the randomness of various sampling populations. So if you wanted to know the average height of the trees in a forest, it's impossible if you just, not impossible, but you would not want to measure every tree in the forest. Okay, it takes forever to do so. So you would take a sample of the trees and measure them to give you a very good predictions to find out what is the mean, what is the average of all the trees. Now, after you find the mean, after you find the average, you would get a number that describes those 10 trees, but how well the number you just got describe all of the trees in the entire forest. So that is what we have to do today. So let's investigate similar situations. Please have some minutes to read the problems. 841. All right. Now let's do it together. Question A. Of course, you cannot wait every robin in town, even though you know how to catch them all, okay? So let's say these are the data we have all a whole town of American robins. All right, so we are going to read the math note box, random samples. So I assume that you read them all, and along with it follows this lesson. What things would be important to do? How can you take a random sample from the population of robins in the envelope provided by the teacher? So let's say this is the one. Discuss with your team. You do not have your team members. So let's look over the answer from my students, my former students from last year. Okay, this is the answer. Do not look in the envelope. Choose one at a time. Shake the envelope. Replace or not replace the birds between samples. Now take a look at question B. Take random samples of 10 robins from our envelope. So let's do it now. We have 87, recording them, the numbers we just take out, okay? So we have 87. The next one, 86. 99. 103. 102. 79. 103. 76. The last one, 91. Question B, calculate the mean. So the mean is average. What you do, you add all the numbers you have from your random sample of 10 robins, 10 of them, okay? Add 10 of these numbers together. 87 plus 86 plus 99 plus 103 plus 102 plus 79 plus 103 plus 76 plus 91. We have total, the sum is 919. Divide it by 10 because there are 10 robins, okay? We have 91.9 grams, okay? All right, question C still. Do you think that your mean is representative of the populations? What inferences, predictions can you make about the population from your sample? Okay, and this is not very a good one for us because we don't have many data. Okay, we only have one data from the teachers, so we should have a lot of data. The more, the better it is. So in this case, on question C, mean is representative because it is random. Means will most likely be between 70 grams and 95 grams. So this is our data, okay? So it is between 70 grams and 95 grams for the mean. All right, let's question D. Compare your estimate of the population means to the means of the other students in your team. It's impossible to do it because we only have one data. Is your mean the true average weight for all American robins in town? Are any of your teammates' numbers the true average? How can you explain any differences between the means? Again, we cannot compare our answer with any other answer because we only have one data. So let's use the data from last year. The answer for question D is no sample can give the true mean. One group could catch large or small birds in their samples. So we cannot get really the true mean, the true average. What is the really true average? Okay, because again, we don't know what we catch. All right, so let's move on to the question A-42. Please have some minutes to read over problem A42. Then we are going to use our data, make a combination histogram and box plot of the previous data. Use a bin with 5 grams, okay? All right, so let's look at our data. This is what we have. The number from our data is not in order, so I have to put them in order from the lowest to the highest number. So starting from 76 all the way up to 103. The median is the middle number. So I am going to cross out 76 on the left, 103 on the right, 79 on the left, 103 on the right, 86, 102, 87, 99. Doing so, it helps me to keep track of my middle numbers, okay? So I have two numbers, 91 and 93. The middle number is 92. So the median is 92. Take 91 plus 93 divided by 2, you will get 92. First quartiles. So we are looking at our lower half data. Lower half data, okay? So I cross out 76, 91, 79, 87. My middle numbers is 86. So my first quartiles is 86. The next one is looking at my upper half data. I have 93 all the way up to 103. So use the same strategies. Take away 93, take away 103, 99, 103. So I have my 102 for my third quartiles right there. All right, the minimum number is 76. The maximum number on the data is 103. So we have everything we need. Now we just plug it in. Okay, we are going to construct the box plot data. So we have a minimum number is 76. So somewhere right here properly is 76 right here. Okay. Next 103. I properly put it down there. 103. Okay. So min max. Median middle number 92. So this properly is 92 somewhere right here. First quartile is 86. So this is 86. Okay. And third quartiles is 102. So put it up there, 102. I'm going to connect all the dots together to make a straight line. Okay. And the first, oops. Okay. Okay. So the first quartiles connect to the third quartiles to form a rectangular box right here. So I just have my box plot created. Okay, continue. The next one, they want us to create a histogram. Use the bin width of 5 grams on your histogram. Okay, so take a look for the frequencies. It's 4x2, 4, 6, 8, 10. So go by 2. Use the width of 5 grams. So you see the intervals. 55 to 60, 60 to 65, 65 to 70, 70 to 75. That's what I want. All right, let's move on. Our data, I'm going to rewrite again. So we have 76, 79, 86, 87, 91, 93, 99, 102, 103, and 103 again. So this data is for the histogram. It's exactly the same data, okay? All right, so my lowest number is 76. So I'm at first, I think I may start it with 75, okay? So from 75 to any number that lower than 80, I have 2 of them right here. So I'm gonna put it up like this. Histogram is just like bar graph, okay? It's used to display numerical data order. So what I have 76 and I have 79. Next bin, I have the number starting from 80 to anything that lower than 85, I have nothing. Next, from 85 to any number lower than 90. So I have 2 of them. I have 86 and 87, okay? 86 and 87. Next, from 90 to any number lower than 95. I have 2 of them again, okay? Which, well, we see number 91. We see number 93, these 2, okay? 91 and 93, my bad. All right, next bin, from 95 to any number that lower than 100, we only have 1. Okay, so this is the one, the only one. And the answer is 99. The final one, from 100 to any number lower than 105, we have 3. So I'm gonna put 3 up there. What are they? 102, 103, and 103. We finished question A. create a histogram and the box plot. We did. All right. Question C. Again, we are going to use the answer from last year. Okay. What causes variation in the sample means? That is why some of the samples means on your class graphs so much larger or smaller than the others. Why are so many of the sample means bunches up in the middle? We only have one data, so it's impossible for us to compare our data with other students' group data. So this is the last year answer. We might have a lot of large birds or small birds in them. There might be an outliers in the sample. The outliers is the one actually affecting to your mean. Okay, so if it is too big or if it is too small, it will be affecting to your average. However, most of the samples you will have collected, typically you will see they have typical birds in them, okay? So the means will bunch up the middle, okay? All right, question C. Use the data from last year again. Within what intervals do you suppose is the true mean? The true mean, okay? No data can find the true mean, but this is the supposed, okay? Weight of American robins. If we have a lot of data, so we can compare our data easily. This is the answer from last year again. Between 75 grams and 90 grams if using the histogram. Between 77 grams and 86 grams if using the first and the third quartiles on the box plot. Okay, let's move on. So for the homework tonight, please go ahead and read the math notes and do the problem 8-45 to 8-50. If you have any question, please email me. I will be helping, I will try my very best to answer those questions as soon as possible. Thank you for your time. Have a great day.